Hey guys, here is a video explaining the statistics review worksheet. So make sure you watch this video after you've already completed the worksheet, and then feel free to jump ahead and just check out the answers and listen to the explanation of anything that you have questions on. So question 1 says the following exam scores on a recent math test are listed in order below. And before we break it down, we'll go into question 2 to find the mean. So the mean, also known as the average, has a symbol X with a bar over it. What you need to do is add all the numbers together, and when you do that, you'll get 1,566. And when you divide that by the total number of math test scores listed, which is 20, you're going to get your average, which will be 78.3. Question 3, to find the median, also known as quartile 2, you are going to start by figuring out the middle number of this list, and luckily they are in order from lowest to highest. So when you find the middle number, you should first circle 72 and 84 are the two middle numbers, and the number that is in between those is going to be 78. So quartile 2 is 78. To find the mode, you're going to figure out what number occurs the most. And this one is kind of a tricky question because there are actually 4 numbers that occur at the same amount of time. So those numbers are 68, 91, 98, and 99. Because each of those numbers occurs twice in our list. Now, to find the range, you are going to take the highest number in your list, which is 99, and subtract the lowest number in your list, which is 55, and you're going to end up with your range, which is going to be 44. To find the lower quartile, also known as Q1, you are going to look at the first set of brackets that you made to the left of quartile 2, and you are going to find the middle number in those first set of brackets. And when you find the middle number here, it's going to be between 64 and 65, which will be 64.5. So quartile 1 is 64.5. The upper quartile, or Q3 as it's also known, is going to be finding the middle number in the second set of brackets, and that middle number, when you circle your two middle numbers in this list, since it's an even amount of terms, you're going to circle 91 and 91, and that means that 91 is quartile 3. To find the interquartile range, you're going to take quartile 3, 91, and subtract quartile 1, 64.5, and when you do that, you're going to end up with 26.5. Okay, on to question 9. In question 9, you have to calculate to see if there is a lower outlier. So you're going to plug in the information that you already found, which is Q1 and the interquartile range, into the formula. Now, when you plug in this information, you always want to check if you're calculating for a lower outlier. You want to plug in the smallest number in your list to see if that's an outlier. And we proved that this is false. 55 is certainly not less than or equal to 24.75, so therefore there are no lower outliers. And remember, this triangle with the 3 dots stands for therefore. Now, when calculating the upper outlier, you always want to plug in the largest number in your list to check if it's an outlier. And since this check proved false, we just proved that therefore there are no upper outliers either. For question 11, you had to figure out if this data involving the student test scores could be considered as qualitative or quantitative, and univariate or bivariate. Once you answer yes or no by circling those words, you had to defend your yes or no answers. So the first one, qualitative. It is not going to be considered qualitative because qualitative would have to be descriptive, and it is not descriptive, versus quantitative, where it's definitely quantitative because it's dealing with numbers. Now, between univariate and bivariate, it could only be one of those two options, so this type of data is definitely univariate because it's dealing with one type of data, test scores. It cannot be bivariate because bivariate would have to be dealing with two different things, two different types of data in comparison. And a good thing to remember here is that between qualitative and quantitative, it's an either-or situation. So when you're dealing with data, it can either be qualitative or quantitative. It can never be both. Same thing with univariate and bivariate. It can either be univariate or bivariate, but it can't be both things at once. And now we're ready to go over to page 20 in our packet to go over the last part of our review. So on the back page, it asks, is there an outlier? Now you're still using the data from all the way from question 1, so we've already figured out that no, there is no outlier. And then it says, if not, make up a test score that would be considered an outlier. So if you look back at questions 9 and 10, you have to come up with a test score that is either less than or equal to 24.75 or greater than or equal to 130.75. Now, even with a bonus, typically test scores aren't over 130.75, so I'm going to pick a number that is smaller than 24.75, so we'll say that there is a test score of 20%. That would definitely be an outlier. But again, you can pick any number in the range that is smaller than or equal to 24.75 or larger than or equal to 130.75. Now, question 13 says, based on the statistical data, what statements could you make about the math test? So these are statements that you are making. So I will pick a variety of answers. Oftentimes one that I use is I say that since a majority of the students passed, and we're assuming passing is 65% or higher, and majority has to be greater than 50%, therefore the math test must have been a fair test, or maybe you say that it's an easy test, or whatever the case might be. And I went ahead and did the math to figure out the percentage of students that passed, and there were 15 out of the 20 test scores that showed 75% of the students passed this exam. So that's how I can say it's a majority, because 75% is definitely larger than 50, and anything larger than 50 is considered majority. Question 14 says, which measure of central tendency, and if you remember central tendency, measure of central tendency are the 3 M's. So you've got your mean, your median, or your mode, would best represent the results on this math test, justify your answer. This is by far the most tricky question that students come across whenever doing this specific review. So first, I'm just going to write down the mean, the median, and the mode from the first page just so I can see it here. Now, as we can see, the mean and the median are just about the same number here, so those are very close, and the mode there's 4 possible modes, so there's no way that the mode could represent this data. Now, when deciding between the mean and the median, you have to consider if there are any outliers. So since there are no outliers that are going to skew the data from one direction or the other, that would mean that the mean, or the average, would best represent the results on this math test. If we had a really high number or a really low number and it skewed the data, then the mean would no longer be an option, and we'd have to decide between the median or the mode. So on to question number 15. So in 15 and 16, we have to find all 3 quartiles, the interquartile range, and then we have to also remember to order the data from low to high. So the first, number 15, is not in order, so we have to do that first. So here's my data listed in order. I always have to start by finding the middle number. Since there is an even amount of numbers, I only have one middle number here, and that's going to be 80. So 80 is going to be my quartile 2, otherwise known as my median. Then I'm going to bracket what is to the left and right of my median to find quartile 1, which is 72, and quartile 3, which is 94. Then I need to find the interquartile range, and that is always going to be the highest quartile, so 94, minus the lowest quartile, 72, and I will end up with my interquartile range is 22. And that's all we had to find. So again, quartile 1, 72, quartile 2, 80, quartile 3, 94, interquartile range 22. For number 16, we again have to find the 3 quartiles and the interquartile range. Luckily, this is in order for us, so we're going to start by finding quartile 2, which is going to be 9. Then we have to bracket what is to the left and right of quartile 2. And for quartile 1, we are going to find that quartile 1 is going to be 5. And quartile 3 is going to be 15. So those are my quartiles, 5, 9, and 15. And then my interquartile range is always going to be the highest quartile minus the lowest quartile. So my highest quartile, Q3, is 15. My lowest quartile, Q1, is 5. So therefore, my interquartile range is going to be 10. Okay, on to the last question. Construct a box plot for number 16 and identify Q1, Q2, Q3, and the lower and upper extremes. So I'm going to first start by making a number line, and I'm going to do that down below. Now my smallest number is 1, my highest number is 18, so I'm going to use each block and count by ones, but I'm not going to write every single number down there. And then I'm going to make my dots at the lower extreme, quartile 1, quartile 2, quartile 3. Notice these are all on the same horizontal line, and the upper extreme, which is at 18, right here. Then I'm going to connect the outer dots because those are the whiskers, and I'm going to make a box around the 3 dots in the center and a line through the middle. And then it says to identify all 3 quartiles, the lower and upper extreme. So I will just write, this is my lower extreme, and this is my upper extreme at these 2 points. And then I also have my quartile 1 at this point, quartile 2 is the center line, and quartile 3 is the other end of my box. And that's going to end this video explaining your statistics review worksheet.